Hi everyone, this video is for section 7.2, rational numbers as exponents. Please make sure that you have the guided notes out in front of you, either printed out or on a separate screen so that you can follow along and take notes. So we're going to break this lesson up into 4 videos. The first one, just dealing with rational exponents, specifically what are they? And before we actually investigate rational exponents, let's just take a brief moment to remind ourselves what a rational number is. So what I want us to remember about a rational number is that it's a number that can be expressed as a fraction. Okay, so this brings us to an example of a rational exponent. So let's go ahead and take a look at 32 raised to the 1/2. And what I want you to do is just evaluate this problem. You'll probably want to have your calculator handy. So if we were to go ahead and enter this into our calculator, it would look like so. So we would first type in the 32, and then since we're going to be dealing with an exponent, we're going to want to use that caret symbol. Remember that caret symbol is located on the left side of the calculator, a little bit above where your 7 key is, if you're working with a standard scientific calculator. After that, we'll do 1/2, or in other words, 1 divided by 2, and we want to put that in parentheses. We want to note that we're raising the entire 32 to a 1/2. So I'll go ahead and write this in red to show you the what it would look like if this were entered in incorrectly. So if we have 32 raised to, say, the 1/2 like so, remember order of operations is going to kick in, and it's going to say, I'm going to do exponents first, but without those grouping symbols, it's just going to raise the 32 to the first power. Then afterwards, it's then going to say, I'll take this result, and then I will divide it by 2. You can imagine that we would get 2 very different answers. If we were to raise this to the 1/2, we should get a not so pretty number of 5.6568542449. And if we were to say round this to the second decimal place, what we want to note is we would locate where the second decimal place is. We would then take a look at the number, or the digit, to its right. And if that number, or that digit, is 5, 6, 7, 8, or 9, we would round up. So this becomes roughly 5.66. So what I want us to now investigate is, well, what about the square root of 32? And remember what we've talked about with regards to indices, or the index of the root. If you don't see anything hanging out on that little shelf where the root is, you can assume that it's a square root. In other words, we use it so commonly that we don't bother including the index number or make it visible. But if it helps, go ahead and put the 2 there. So what I want you to note here is take a look at the index and take a look at the denominator of your rational exponent. This may not be a coincidence. So if we were to type in the square root of 32 into our calculator, lo and behold, we get the same exact number. So there might be a connection that's happening. Let's continue with another example. Say that we work with 27 raised to the 1/3 power. Again, if you were typing this into your calculator, we would do 27 caret parentheses 1 divided by 3 close parentheses. In this situation, we get 3. Do you think that there's a way that you could write this so that instead of it looking like an exponent problem, we can write it so that it looks like a radical problem, or in other words, a problem that's using a root instead? And hopefully, what we're kind of noting is we're going to do 27. And if we do the root, again, what I want to note is the denominator is a 3 in your radical exponent. Or sorry, rational exponent. If we go to the radical side of things, we should have an index of 3. If we were to type this into our calculator, here's what we would need to do. We would first type in a 3, then we would hit our second key, followed by our caret key. So these two keys together are going to give you this on the screen of your calculator. So in other words, what we have here is we have a third root. This 3 is going to kind of act like this x. From there, we would type in 27, and again, we should get a result of 3. Hopefully, so far, so good. If you do have any questions, please do not hesitate to reach out to me. So let's spend some time on some notes here in your guided notes. So the first one, we're going to note when the base of your exponent is non-negative. So in other words, by non-negative, I mean 0 or a positive number. The index can be any natural number and I'm going to fill this in a moment, greater than 1. So just in case you need a reminder or a refresher on natural numbers start at 1 and we just count up. So we do not include any decimal or fraction values, so it's just a list going from 1, 2, 3, 4, 5, and so on. And what this is saying is, we're saying that if we are writing our exponent as a radical instead, what we're saying is we can only use indices or an index on the root that is greater than 1. So in other words, I can really only work with numbers starting from 2 and going up. So an example of this, for example, first we would need a base, or in other words, a radicand value that is non-negative. So I'm just going to work with, say, 54. And if I'm working with a radical sign, I can use any index as long as it is 2 or bigger. So I might use, I'll be a little bit ridiculous and use 23. This fits what's being stated above, okay? However, we need to consider, well, what happens if your base is negative? So when the base is negative, the index can be any odd natural number greater than 1. So again, if we come back to our natural numbers, but noting this time that I'm going to work with a negative base or radicand when I come to my root, I want to note that I can only use index values that are odd and bigger than 1. So in this case, I should be okay to take the cubed root of negative 7. Because again, remember we can kind of come through and say, well, with a negative number, I can break that negative 1 into negative 1 times negative 1 times negative 1, which then allows me to group them. So I have a group of 3, and then I can take that particular root. So in other words, I can kick that negative outside of the radical sign. All right, so we just have a few problems that we're going to explore for the rest of this part, and then we will move on to part 2. So the first one, we're just going to focus on translating right now. So let's not worry about too much cleanup. Like if we have some simplified, if we have some basic number ones, we'll go ahead and we'll clean it up. But we're really not going to dive too deeply until later on. So say we have the fourth root of 2ac. So in this problem, I want to go from a radical expression to an exponential expression. So what this is saying is, again, I'm going to take my radicand and I'm going to use that as my base. I'm going to put grouping symbols around it to indicate that I'm going to, that they're all together. They're all having this particular operation done to them. So the first thing that I want to note is, well, if I were to group them, say, underneath the radical sign like so, what power are they being raised to? If you look at that exponential position, and hopefully you're thinking, well, they're being raised to the first power here. So they're going to still stay being raised to the first power. I'm going to take a look at that index, and I'm going to send it to the denominator position. So the fourth root of 2 times a times c is the same thing as 2ac, all raised to the 1/4 power. The next question that we're going to look at is going to be 1,000 raised to the 2/3. So there's a couple of ways that we can look at this one. Okay. The difference here is we're going in the other direction, so we're going to go exponential to radical. One way to look at this, I can say, all right, I see that I have a denominator of 3, and I'm going to send this over. This would give me a cubed root, and I can leave the 1,000 squared underneath here. In this particular case with these numbers, this is relatively easy to work with and clean up. So what I want to note, I'm going to go ahead and expand this out a little bit more. So instead of 1,000 squared, I'm just going to take it one step back and do 1,000 times 1,000. The reason for this is, well, do we agree that 1,000 is the same thing as 10 times 10 times 10? If you don't believe me, feel free to jump to your calculator and double check. Well, I note that I have a cubed root. I have a group of 3 tens here and a group of 3 tens here. This is then going to allow me to break this group out as well as this group. So I have 10 times 10, and I can clean that up and I get a solution of 100. Just in case some of you are wondering, does the square always have to be underneath the radical? The answer is no. As long as the square portion of this number stays in the exponent position, whether underneath or outside of the radical, you're good. So let me explain a little bit more. So again, you could have rewritten this as your cube root of 1,000, but then just noted that the entire thing will be squared. Essentially, the only difference that you're noting here is that the square was underneath in this example, and instead I could have pulled it outside. Okay, I'll show you that this should not have an impact on your final answer. So again, hopefully we're noting, well, I still have 1,000 underneath here, so that's 10 times 10 times 10. This means that the cube root of 1,000 is going to be that 10, and I still have the square on the outside, which is still 10 times 10, which is still 100. So play around with it. You might find that one way is better than another in certain problems. There isn't necessarily going to be one perfect way to simplify or evaluate these cases. So I would say play around with it, see what works for you, see if you can actually kind of come up with some tips for yourself or develop that intuition. And you're only going to be able to develop that intuition through practice. All right, so the next one that we have the fifth root of 4x, and we're going to raise that to the third power. I just want you to take this from the radical to the exponential. So again, my base is going to come from that radicand. I'm going to note here that I have the 3 in the exponent position, so the 3 will stay in the exponent position. The 5 is the index of the root, and I'm going to pull that over to leave it in the denominator. Okay, the only thing that I might suggest here that I'm not quite done, I want to make sure that I keep my 4x in grouping symbols. If I didn't have those parentheses around it, it would only look like the x is being raised to the 3/4 power, when I really should have both the 4 and x being raised to that exponent. All right, so last problem, very similar to the one that we just worked on. We are going to work with the 7th root of 6z, and 6z is being raised to the 8th power underneath. Okay, so we're still going to go from radical to exponential. So what I want you to note is we have a lot of it kind of done already. We have our full radicand hanging out there underneath. So we have our 6z, and we still want to note that it's being raised to the 8th power, so this exponent in the exponent position stays the same. The only difference is now I'm going to take a look at, I have the 7th root, and I'm going to move it into the denominator position. So 6z raised to the 8/7 is my final solution. I hope this was helpful. If you have any other questions, please let me know.